This is Ken Forster, and we are going to kick off our session of Edge AI and Digital Twin. Actually, two very interesting topics together. To start with, I'm going to ask each of the team members to go ahead and introduce themselves, and we're going to do it in, I guess, alphabetical order here. And then we've got a whole series of questions, and hopefully along the way we'll have time to entertain Q&A from you guys as well. So Ken Forster, I'm Executive Director of Momenta. We're a leading digital industry venture capital firm. We focus on digital innovators across energy, manufacturing, smart spaces, and supply chain, and are close to being a decade old, so quite proud. With that, Bharath, I think you're up next.
Yeah, thanks, Ken. Bharath Ramesh, I head product management and strategy for Edge at HPE, and I'm actually at one of those rare face-to-face events, so I apologize if my video or audio aren't perfect, but very excited to be able to join this panel.
Excellent. Bill?
Hey, Bill Roberts with SAS. I run our IoT division and run product management and industry advisory within the division. So happy to be here, happy to be part of the conversation.
Great. Robert?
Robert Marcus, hi, speaking to you from Aix-en-Provence in the south of France, CEO of Alpha 10X, an AI startup concentrated on predicting the future of innovation, strong focus on edge computing, and former VC concentrated on AI and edge computing. Thanks for having me.
All right, and we'll finish up with Tom.
Great, hi Ken. Tom Arthur, I'm CEO of Dianomic. We're a major contributor to an open source 4.0 platform called Fledge. And it's been adopted by the Linux Foundation Edge Group, LF Energy, which is another group of energy companies on green energy, as well as being tested now as the Edge technology for OSDU, which is a series of about 160 oil and gas companies building open source tools for their markets.
Excellent. So we great all-star panel. We have two investors in the space, two representatives from very large players in the space, and Tom, the innovator and disruptor in that. So it's a good collection, all bringing it all together. So we're going to start off just to define what we mean by Edge AI. And actually, I'll ask you guys kind of in the same order we just introduced ourselves. Give us your perspective of what you believe Edge AI is. Bill?
Okay, I'm happy to take this one on first. Thank you. So, I mean, Edge is obviously anything that it can be defined as anything not cloud as far as that is concerned, and being able to operate Edge or AI or machine learning workloads in that often distributed network architecture that takes you down close to where the data's created, right, where it makes sense based on the use cases you're trying to fulfill. So I hate to define things by what they're not, but Edge to me is kind of a really broad construct. And, what we know is it's not your on-prem traditional data center and not your cloud. So everything that lives kind of outside that might be at some level defined as Edge.
Yeah. What about Edge AI particularly?
Right. Being able to take and train models maybe in your data centers or cloud, be able to run these algorithms against data very close to where the data is created, obviously driving latency, bandwidth, and other concerns out of it, so that you can really capitalize on the opportunities of the use cases that they're fulfilling, right? So, yep, being able to drive those algorithms close to where that data is created.
All right. What's the HP perspective, Bharath?
Yeah, and when I look at the Edge, I really see it as a massive data source, because when you think about it, what is the data you collect at the Edge? It's data from nature, pressure, temperature, vibration, light, sound, and that data is very high volume, that data is very high velocity, and the reason customers look to AI is because managing and processing that data is really, really difficult using traditional methods like statistical analysis or heuristics. But when you start using AI, where you're building models based on sample data, you're deploying those models at scale using proven techniques, it becomes a much easier problem for them to address. And really, the transformation that's happening is techniques and tools that we've used in the data center and cloud to do AI. Now those tools are available at the Edge. And so it's really giving rise to this phenomenon of using Edge AI to solve those data management and analytics problems.
What about the investor perspective, Robert?
The investor perspective. Well, first of all, to me, the AI, I think the metaphor to me is the AI is the brain, and I think Edge is something of the nervous system that is transmitting all the messages, but the brain is making sense of it. So from an investment point of view, I think the opportunity around the nervous system, the edge aspect of things is very much a long play. Yeah. But when it comes to value and early monetization, I think it's going to be around the AI, the brain that makes sense of all the signaling that is being transmitted. I think the early opportunity is very much at the AI level, sitting on top of the edge.
Okay. Tom?
I think everyone pretty much had what I would define. I would say inference run on the edge. So when you have a model actually sitting on the edge, you now have your current streaming data, whether it's accelerometers, PLC data, or a camera, and the inference actually runs in some compute engine. I have an industrial bias, so it's usually next to the machine or the data source of a machine. So it's next to the PLC or it's next to the SCADA system or the DCS, because that's where the data is and you can process that high definition data there.
Yeah, I think to all of those definitions, I'd add the idea of data in motion. It really is good for data in motion applications, right? Versus data at rest, which would be a good cloud application. Speaking of apps, and what do you see as the killer app for Edge AI? And Tom, I'm going to allow you to start with that because I know you're going to say Fledge.
No, I'll say OEE. I think the killer apps are usually related to OEE in industrial cases. So the real return on investment is usually an optimization on a process or quality control. The sooner in discrete manufacturing you can find a defect, the better. And you can save a lot of money if you do that early in the process before you attach whatever that part is to that car and you'll learn it a year later with the customer in a recall. That's expensive. So if I can do it at the assembly line, all the better. So OEE applications.
All right, Bill, what about your perspective?
I like Tom's feedback there. I think of computer vision in service of in industrial, certainly some type of quality or process monitoring application. Computer vision kind of lends itself there, right? Because if you're going to try and do it in the cloud, you're going to have a lot of cost and latency there. But if you can actually deploy your CV to Edge, you can cut that out and have a nice impact from what Tom has said in his reply. So I kind of like the computer vision angle with that question.
All right, Bharath or Robert, anything you want to add in terms of your idea of what the killer app is for Edge AI?
Yeah, no, I think any kind of image and video analysis really is about as good as you can get when it comes to applying AI at the edge, because I view cameras as kind of a universal sensor. There's a ton of metadata embedded in it. It could be looking for defects in parts. It could be looking at shopper behavior, facial recognition, theft detection, whatnot, right? So latching onto existing video and image infrastructure, but now being able to apply AI techniques, inferencing and neural networks in particular, to that data is unlocking value on data you already have. Because those CCTV cameras, those QA cameras, they're already there. All you're doing is applying a different type of analysis on it. And we've come a long way from where AI used to be, right? I remember in 2012, the Google Brain project came out. They needed 16,000 computers to identify pictures of cats. And today your iPhone can probably do that, right? So the ability to do AI in an economical, in a very compact and efficient way, we've come a really long way. And I see image and video analysis being one of those killer data use cases for AI.
Yeah, fully agreed. Robert, anything you want to add?
I think I would just, I'd confirm the augmented reality aspect of the equation as being super high value. And then I think in the medium term, autonomous vehicles are definitely the killer app for Edge.
Yeah, definitely. Almost autonomous anything at this point. We
autonomous anything, drones,
robotics,
everything.
AGVs, etc. Yeah. What have you guys seen are the biggest challenges for deploying AI in the real world? And perhaps, Bharath, I'll start with you on this one.
Yeah, sure. I think it comes around like how do you get access to the data? Because Tom mentioned industrial systems. A big challenge our customers run into is a lot of the systems are closed proprietary systems. How do you get to the data? That's kind of a day zero problem you need to solve. And then once you get access to the data, how do you cleanse the data? How do you get rid of all the noise, bad images, sensor feed dropouts? How do you then use that to create your AI training models? Because it's truly garbage in, garbage out, right? If you don't have high quality label data that you're training the model in, it's going to produce junk. And then once you do get the model, how do I prune it down so it's only recognizing what I want it to recognize? Because, a good analogy is if I'm training it based on pictures of cars, that model is going to pick up trees, it's going to pick up animals, it's going to learn to recognize things that you don't really care about. And so cutting the model down, optimizing it, and then being able to deploy it at scale across multiple edges, and then being able to monitor how the model is drifting, as your data is changing, as your physical asset concepts are changing. How do you make sure the model drift is monitored and it's recurringly being retrained so it maintains its predictive accuracy? And then finally, I would say security and reliability, because you got to have that across. That's not an afterthought. That's something you got to do right at the get-go.
Bill, what's the SaaS perspective?
Well, I think Bharath, covered it in a lot of ways. I mean, everything's a challenge when you're trying to push these models into production and pushing them out to an edge, which may be an operational environment and non-standard from an IT perspective, just adds complexity to that thing. But what we think about is the analytic lifecycle, and it really doesn't matter where you're deploying the model. You still have core things that you need to worry about when you're developing an AI or machine learning type model. How you're training the model, the data you're using, and then understanding when you do deploy the model, how are you, as Bharath mentioned, how are you going to govern that model, right? And how are you going to ensure that that model is returning the kind of results that you expect over time, manage drift and other things? So it's basically creating that entire modeling life cycle that enables it to become a useful asset within the organization, right? And so in building an environment where regardless of you're not limited by where the model is going to run as to how you're going to end up building the model, right? So if you have to worry about that up front, you may be selling yourself short on the tools or capabilities you're trying to use in order to develop the model, right? What you need to do is understand your use case, develop the model that satisfies the results, right? And then let the use case define where you need to deploy that model and not have a bunch of trade-offs because you're going to throw that model out to the edge because that's where it needs to be in order to drive value back to the organization. So being able to extend that life cycle to include the edge is just part of your modeling paradigm.
Any other deployment challenges for AI, Robert or Tom, that you would add in there?
I think the biggest one that we run into is it usually is a subject matter expert that has to be involved in the labeling. And this person generally isn't a computer scientist. This person doesn't know JSON or Python. This person knows a pump. And so when you involve a guy that knows a pump and you're getting maybe PLC data from that and accelerometer data from that, you also need to experience, let's say, the defects that you're trying to, let's say this is used for anomaly detection on predictive maintenance of this pump. You need to experience those defects in that pump, in that data, before you can build that model. So if you only put your data acquisition on one pump and that pump messes up once a year, you might be waiting a year to have example data to build your model with. So you need the data acquisition, enough data from enough different pumps and the likelihood of seeing those defects over time. You need to reduce that down. You need to make that a lot more efficient. So a lot of our challenges is in the subject matter expert who's a non-programmer, getting that data, experiencing the defect, labeling that data, and going from there. That's a big part of the challenge we found.
Yeah, so the training overall, the ML training per se. Robert, anything you want to add to that?
Just would confirm all of the technical issues that have been raised completely. But coming at this from more of an investor point of view, I think the primary deployment issue is monetization. Who is going to make money in the value chain and how? What are the monetization modalities? How do you make money? Is it usage? What is the? I think all of this is yet to be clarified, and that until we clarify that and people really start to make money, deployment will be slow and kind of we're dealing with a latency issue on the edge side of things, but a latency around building the business is going to be really driven by monetization.
Hmm. So we had two topics coming into this. Jason put together for us: AI and digital twin. How do you guys view the relationship between AI and digital twin? These two, and perhaps Robert, I can start with you on this one.
Yeah, to me, it's all about simulation. The digital twin offers us an opportunity to simulate pretty much anything. I'm particularly focused on impact investing as a category. So anything related to climate, the pandemic, you name it, the ability to simulate, predict is in the twin environment is where the value is driven from my point of view.
Okay. Bill, what about the SaaS perspective?
Yeah, I mean, it's a great starting point. You know, if you have a good digital twin, maybe it's based on first principles. You know, then you're able to start collecting data that really describes how that asset kind of lives in context. And the AI can help you fill in the blanks from your physics-based model that you may not have. It's also going to help you explain the variation of what that asset looks like in its systems. So I think that it's a fantastic tool. It's a fantastic tool for simulations and for understanding where anomalies and variation is starting to impact what it is you're focusing on. So I see them as very complementary in that respect.
Bharath, Tom, anything you guys want to add into this?
Yeah, sure. So, I think especially for modeling a physical asset as a digital twin, we have to accept that inevitably any physical system moves towards entropy, right? Oil breaks down, valves start to wear out, seals start to wiggle around. So the physical asset is going to change, and your digital twin that you build initially needs to evolve because it needs to track what's happening with the physical asset. And this is where I really see AI helping out, because in the past, if it was built based on a statistical model, you need somebody, a subject matter expert, sitting and babysitting that digital twin and making sure that it's reflecting reality. With AI, some of that workload, not all of it, but some of it can be automated, right? You could have model drift detection that I mentioned, driving recurrent retraining of those digital twins. So at least the twin is evolving to a point where the human can intervene less frequently, but the model is kept fresh. So therefore you can trust the predictions that model is making. And because you're doing all this at the edge, there's less dependency on you being connected back to a cloud to be able to keep that model refreshed, right? And this becomes very relevant if you're thinking about a digital twin running on a oil rig in the Gulf of Mexico. Connectivity is a scarce commodity, and you want to be able to do that model maintenance and retraining at the edge itself. So I really see AI as being a way to keep those models relevant without needing a ton of SME attention all the time.
Tom, anything you want to add?
Well, our first experience with a digital twin was actually kind of a fun one. It was with Honda's GT3 race team, and it was actually sponsored through Google, which was interesting. So the digital twin was actually the tracks. They run on about a dozen tracks. And so they would use computer vision to map exactly all the different tracks. And then they called them simulators. So they had a simulator for the car, and they had a simulator for a driver. And then so they would put this digital twin of the track, and they could change the configuration of the car and change how the driver drove the track. And by doing that, they would optimize the car's configuration before a race. And so it's, I think, the combination of being able to do these simulations against some sort of, in this case, digital twin of the track to optimize some process in that case. It was a fun project.
A very interesting use case. Yeah, quite unique, but actually very practical in that. So perhaps tell us about some other practical use cases you guys have worked on in leveraging Edge AI. And Bill, I'll start with you on this one this time.
Sure. So we do have a bit of experience now working with Edge and driving analytics down to the edge. My experience has primarily been in the industrial sense, a little bit like Tom in that respect, and using most recently computer vision to help with a wallboard manufacturer manage production. You can, wallboard has a very long production line as things move down, and being able to use computer vision to watch what's happening as the wallboard shifts on that line, and you can actually use it to identify where you might be getting binds or overlaps that can create, essentially production binds, right? And that, I think, is a really interesting use because they just don't have enough people to watch the entire length of the line all the time. So a computer can watch it, and it actually brought up some really interesting architectural questions. Our prototype was done on security cameras, right? Okay. Which was an interesting use of existing architecture in order to drive some benefit. But in the long run, that wasn't really a strong, sustainable direction, right? So there's the concept of being able to say, okay, if we really want to do this right, we might want to think about a different architecture using more specialized cameras and equipment that has some compute right there on the camera where we can do the inferencing, so we're not moving so much data around a plant, right, in order to drive the event. It's very cool to say for a POC, do something that leverages, existing equipment, but then you have to think about, okay, for an operational deployment, where does this look, right? And today there's lots of options now if you want to use, cameras that have, strong compute capability where we can drive what we need there and handle some of the other things that we've spoken about as far as security and connectivity. We are able to take the same thing down to remote devices, such as locomotives, being able to use capability within the locomotive to do the processing right there, looking for track damage, leveraging imaging on the trains, right? And so as the trains are moving, you're constantly getting feedback. Hey, this area of track needs attention for, and you can name your type of failure modes that the track may be suffering, so that you're really optimizing the way you're supporting your track. So I started with kind of computer vision as the killer app, and I think those would be the two use cases I'll surface there, both kind of computer driven, vision driven.
Yeah, one of our earliest investment thesis was this idea of video at the edge. It's how I got to know Jason when he was prior at Dell, because obviously he was pushing their gateway line, right? And that was the closest you could get to putting processing at the edge. But one of our early investments was a company called IoT Innovations that's doing a lot of automotive related, like quality control, things like that. And same thing, starting with existing cameras and then ultimately going for fit for purpose FLIR cameras, traditionally IR. And so some very interesting use cases in that. Tom, I know you already offered an interesting use case already, but anything else you might want to throw in there?
We got two that I think are real interesting right now. It's funny you mentioned FLIR. FLIR's actually an OEM of Fledge, so I will brag about that. So FLIR is embedding with their infrared cameras. And one of their use cases is a large bottle manufacturer. And so when you think beer bottle, Budweiser, right? So when you think about that, it comes out of this mold, it's about 1,000 degrees, and it's about an hour down the line when they detect defects in this bottle. So they've had an hour's worth of manufacturing. So we're playing with the infrared camera, so you're getting the image file and radiometric data, actually. So every pixel actually has a location and a value in that pixel. So using that to identify, right when it comes out of the mold, about a dozen different types of common defects in a bottle to save an hour's worth of production to catch it earlier. That's one. We're doing accelerometers with a very large food manufacturer on centrifuges. So they use centrifuges to purify food oil, and the last step of the line is in the centrifuge. You still have little particles of in this case it's canola oil, so of the seeds in there, and they want to be able to predict the amount of water that's in the centrifuge with these particles, because they have a process called a chute, which lets the impurities out and the purified oil goes out. But they don't want to do a chute because they lose gross margin every time they do it. So they want to operate it safely, but they want to maximize gross margin. And can you use AI and vibration data to determine the amount of particulate and water in a centrifuge?
Very interesting. Robert, Bharath, anything you guys want to add?
Maybe I just add the fact that you have 5 guys here. Of course, you're too many guys, but 5 guys wearing glasses. So I think I think the augmented reality opportunity is, well, I've done a lot of work in that domain. I think it's absolutely huge. We will reach a point sooner rather than later where data is streaming in a traditional lens. Then the question is what data and how is AI filtering out the data and that type of thing. It's a little terrifying. My team have come up with a dating app So you're sitting in a date and you're getting, real-time data and signals being interpreted by the AI and that type. I think this is the world that we're headed towards. But I think augmented reality is a very real and close use case. Huge issues around the physics of the lens and power and that type of thing, but we will solve them, and then that will become a very big business.
Yeah, speaking of, I guess, video, edge AI, and personally identifiable information, or privacy, if you will. There has been, it seems to be a big uptick in certainly kind of surveillanceware, if you will, from video analytics at for queuing at airports to, of course, security in a lot of cities and such. And of course, Robert and I are sitting in Europe proper, so GDPR comes to mind pretty quickly in terms of how you protect against that. I guess from your guys' perspective, how do you feel like Edge AI will be able to help in terms of ensuring protecting privacy at the edge, and also helping, especially with known as fake data, if you will, ingestion as well. In that regard, Robert, I guess, what's your perspective?
I think it can help. I think it'll be a throttle to some degree, but what a huge issue! I mean, this is going to take decades to resolve. Extremely complex issue. AI can help function as a firewall of some sort and a throttle, but a huge problem to be solved.
Yeah, Bill, what's your perspective?
Well, I would see it the same way. I mean, Robert described it as a throttle. Unfortunately, oversight and is going to be necessary, a continued oversight. I do think that folks who are building AI applications have some responsibility to think about a range of issues that can be used as they consider the data that they're using and consider what they're trying to achieve with the AI that they're building. And within each step of building an AI, an algorithm, you can basically open yourself up to more or less bias and other things. So these are very true. Having very clear goals and objectives and understanding how those are being served when you actually build a model, I think will be important. And then having governance and oversight is going to be important. I really thought this was an interesting question. Fake data, synthetic data is a really important tool when we're building, for productivity and for building AI and machine learning models. Yet there is this other side of it that, there's other data. So it's almost like AI for good or AI for evil kind of paradigm, right? And so, you're going to have oversight when you're looking at the way these models are performing and what the goals are. In order to ensure people aren't using it for evil.
Yeah, several companies we've been looking at in the usually in queuing, line counting applications. So think malls, shopping, or airports, things like that. That is a big part of what we look for, is the ability to basically edit out in real time the anything personally identifiable, right? In that regard, and it's still relatively rare in terms of finding good software that will do that, or supported by hardware. So I personally think Edge AI will go a long ways toward helping that. Tom, Bharath, anything you guys want to add?
Yeah, sure. I'm going to have a slightly different take on it, which is how do you prevent malicious actors from misleading your AI model? Because I take an analogy of an ice cream factory, right? The attack vector is frequently not the compute. It'll be the temperature sensor that causes your compute system to say, turn off the chiller. So how do you ensure authenticity of data coming into your AI model? And how do you do that by extending the realm of trust as close to the sensor as possible? Because like it or not, a lot of sensors today, they're really dumb devices. I mean, they're generating an analog signal or a simple bit stream that says, this is my temperature. How quickly can you intercept that stream? How quickly can you hash it, encrypt it, bring it into a trusted system? So, because that's really where you start having control over the modification of that data, right? And I think that's the big challenge, because it's going to cost a lot of money to be able to extend the zone of trust out there and to ensure the quality of data starts from the time it's collected, as opposed to after it's sent over a gateway to some cloud or whatnot. So I think really what we're seeing around AI both used to make the predictions, but AI also used to detect anomalies, because you can create signatures that detect data drift, concept drift. You can assign risk weight to it. So you can start setting thresholds, saying at what point do you need a human to come in and see, why is this anomaly? Is it real? Is it actually the device changing its characteristics, or is somebody trying to tamper with it? We're already seeing this being deployed in the realm of like network analytics, looking for malicious devices being connected to a wireless network. We have products in HP that address that, but we're seeing those being extended to other realms, for example, industrial as well, because having provenance on where the data is collected and trust that the data is authentic is critical, because you're betting your business on it, and you don't want to bet your business on data you don't trust.
That's a really good point. Just to add, I mean, when you started speaking, it can be just a common issue. You're going to build an AI model of some sort. You're going to build your training set, and you clean out all of the noise of the data, right? And then you go and put your model into production. All of a sudden, you're getting all of these zero reads from a sensor, right? And the model isn't going to be used to that, right? So understanding how your data actually is produced when you're building your model, I think is a really important construct, and extending the area of trust is obviously a great point as well.
Yeah, we've seen certainly an uptick in the number of companies that are developing training tools for ML and AI. Whether it's a video or visual training tools or otherwise, and it's an interesting area to think about in terms of venture capital investment, right? Sustainability of an investment, to have a training tool for the thing that's actually going to create the value. So it is interesting how many that we've seen. Tom, anything you want to add into the conversation?
I might do that. Bill kind of talked about just briefly, but I'll do the glass half full. Synthetic data is very, very useful for model building. So like in industrial space, if some gearbox rotates these gears at this rate, you can pull out an FFT with synthetic data and look for specific things, about a machine if you know it up front, without having to go find actual data. And it can really enable a model, and a very accurate model, fast.
Okay. So put you guys on the spot. You get to put your prognosticator hat on. What do you see as the major trends in Edge AI over the next several years? And Tom, I'm going to start with you.
Where we try to commercialize our businesses in management. So there's a lot to do in the life cycle of Edge ML. And so we're spending a lot of time on how do you build tools to do these problems of data acquisition, labeling the data, getting it to the data scientists. And tomorrow, if you have a factory with thousands of models, how do you get the right model to the right compute? How do you update those models? So scaling that whole life cycle is obviously necessary to build that automated factory. So I think there's going to be a lot of investment and opportunity there.
All right, Robert?
I would say it would be the moment in time when sufficient revenue can be generated by applications developers that you see a proliferation of apps, that drive demand for the underlying edge infrastructure, and these will be primarily AI-based apps. So I think when developers start to see an ability to make significant money on top of edge, then you'll see a complete transformation along the lines of what we saw in 2007, when the walled garden of the mobile network came crumbling down and you saw millions of apps and the whole world changed. I think we'll see a similar scenario over here. It may be that we're still a couple of years away from that, but when that happens, everything changes.
Bill?
Well, I can't disagree with either of those suggestions. I think that we're already seeing it. There's a lot of work on the hardware side, AI chipsets that are moving to the edge, which are changing the way models perform and where the edge exists, right? These chipsets are optimized for the use of AI and machine learning, low power consumption, high availability, high power, almost like the consumer edge, in the phones, that's transferring kind of over to the industrial area. So I think that is a trend that will continue, and as a software provider, we'll be able to continue to take advantage of those changes.
And Bharath, what do you see as the major trends in Edge AI over the next several years?
Yeah, let me latch on to what Bill said, right? I think inferencing at the edge has been democratized. I mean, 6 years ago when we at HP started this big edge compute push to build enterprise compute at the edge, inferencing was a tough problem. It was expensive, power hungry, needed a ton of hand holding to get that running. Today, that's no longer the case. And I'm kind of seeing training moving in the same direction. We already know technologies like swarm learning are going to allow a decentralized training process. Today, training is very much a data center or a cloud thing, but swarm learning is going to let that happen at the edge. It's going to allow the edges to collaborate. It's going to allow devices already at the edge, potentially inferencing devices, to participate in the training. And in my opinion, that's really going to open up the ability to do training and recurrent retraining at the edge, because you no longer need those really large compute instances at every edges. And we know there are lots of edges, right? Manufacturing, for example, space and power are big deals. You cannot put a big training server at 500 or 1,000 watts at every one of those edges. You can put really small, tens of watts compute devices doing inferencing in the daytime, and maybe participating in swarm learning at night when the production is at a lower velocity. So I think it's really democratization of AI training and doing it at the edge in a collaborative way that I see as the really big trend following inferencing.
I had somebody I was talking with recently, and he heads up a company that does data ops, and he basically said all of this will go away with what he calls auto ML, which I think he's referring to exactly what you're saying, right? The ability to basically learn at the edge, and thus data ops will be the real key at the end to make sure you have good, clean contextual data. So a couple questions have come in on the Q&A side of it. Let me kind of summarize the first one. Will Edge AI be more adaptable than standard AI on cloud, since industries tend to adopt as many stages in the product life cycles? Anybody want to take a jump at that one?
Yeah, I can start off, right? So our fundamental grounding principle for AI at the edge is it should use the same tool sets and techniques that we have used to build and deploy AI at scale in the data center and cloud, because no customer I've talked to has said, I want to do different things just because I physically locate this algorithm at the edge. So I think it's adoption of technologies we've proven can be scaled, can be easily tweaked in the data center, and simply lifting and shifting them to run at the edge. I think that's going to be the critical enabler for this adaptability, because you're right. I mean, every production line, every industry, they're going to need 20-30% tweaking to make that AI model fit for their use. But 70% of the stack is identical, and that can be based on proven technologies in the data center or cloud.
Okay. Well, we got about a minute left. I'm going to ask each of you to give maybe your 10-second parting shot at what you'd like to leave the audience with relative to Edge AI and to digital twin. And we'll do like we like to do, and we'll go alphabetical order. So Bharath, I'm going to put you on the spot first.
Yeah, no worries. I mean, I think fundamentally it's like prove your ROI, right? It really comes down to two things in my mind. One is, can I reduce cost? Can I grow my revenue, right? And you need to be able to relate Edge AI to those two metrics, because that's where you're going to get the investment. Frequently, it's line of business investment. This is not investment coming from a centralized IT budget. So you need to be able to convince the QA director or some guy doing shrinkage reduction in a retail store that there is an ROI to deploying AI at scale at the edge. And I think if we don't start with that as our grounding metric, you're going to end up with these wonderful POCs that never really translate into production deployments.
ROI, love it. Bill, what's your thought?
Well said, ROI. I guess the second thing I would add is that, yes, it's important to consider the edge cloud wherever, but first you start with the use case and the ROI. Then you think about what your architecture is, and there's no value in just throwing things out to the edge because 5 guys on a panel said it was the right or cool thing to do, right? And you definitely have to architect it based on what it is you're trying to achieve. So I would just use that as well. Perfect.
Robert?
To me, it's all about the reality that each successive wave of computing produces new leaders. So the question to me is, who is going to lead in this wave? And I think it is edge, it is AI, but it's also quantum, it's nanobiotechnologies. These are all intersecting at the same time, moving us towards the singularity, whatever you want to call it, and who is going to lead in this wave? Is the big cloud players, will the cloud players lead? Are there completely new entrants that will dominate the space. I think it's wide open to new leadership here. Very exciting time.
So I'll leave the single word of singularity. Tom, how do you top that one?
I was going to go tactical because I agree 100% with Bharath. I've learned it's ROI, ROI, ROI. And the hardest part about that is most people don't know how efficient they currently are. So what is your current baseline? How efficient are you right now? Has to be very well understood before you can prove the opportunity for better efficiency. And that's actually harder than you think.
Yeah, well said. So Tom, Bill, Bharath, Robert, thank you all very much for the time. Jason and ZEDEDA, thank you for giving us the honor of being able to participate in this great event. And you all have a great day.